So that is how we can say the application of resonance is there. Now comes the resonance, that is the frequency response of a circuit or any network, we can say for that matter. And when it's operating at its natural frequency, and that particular frequency we could name it as the resonant frequency. Okay, so in that case we can say that the resonant frequency for such just a minute. Resonant frequency for such we can say cases, they can be denoted or they can be named as the resonant frequency of a particular material. Fine. Now in this we can say RLC circuits which we are studying, if we consider this we can say kind of resonant circuit, in that case we can say that series, if you talk of some series, there can be either resonance in the series circuit or it can be in the parallel circuits. In this case we can say if you talk of the resonant series circuit, that can be taken as an we can say application of a voltage amplifier first, and in case of a parallel resonant circuit, that was a current amplifier. Means amplification means increasing the we can say amplitude of a particular quantity, that we call as the amplifier. Okay, so similarly, if you now come to a resonant condition, what actually in case of a really this series RLC circuit, the resonant condition is. So we can say when the capacitive and inductive reactances, they are equal or they are same in magnitude. Two things are there. We had also already discussed. One was regarding the magnitude, and another is regarding your magnitude and the angle, we can say. So that we had discussed
Angle.
yes, that we had discussed in case of the AC circuit. In AC circuits we say that there is one magnitude and there will be one some sort of angle or the direction of the particular quantity. So for that, if you see the input impedance, that can be taken as Z, which is R plus j omega L plus j omega C. That means this will be your we can say XL and this will be your XC. Fine. So, in case of the resonant condition or in case of the resonance, we can say this net resonance, that is XL minus XC, they that become equal to 0. Or for that matter, we can say omega R, that is the resonant frequency at resonant condition. So that is omega R. So that we call as resonant frequency. That is omega RL is equal to 1 by omega R C. That means this resonant frequency omega R, which we need to calculate, is equal to 1 by under root of LC. This is a clear expression to everybody. Expression, this is very simple, that at resonant condition we can say these two values, that is R plus j omega L and j omega C, they are equal, or we can say the difference or the net value between them, that is equal to 0. And from that we could find this particular condition for calculating the resonant frequency in radians if it is. So we can say omega R, that is the resonant frequency, that is 1 upon under root of LC radians per second. This is clear to everybody?
Yes, ma'am.
Yes, ma'am.
Next
Yes, ma'am.
of the resonant frequency, and we measure it in hertz, that is FR. So that value will be obviously omega R, that is 1 by 2 pi under root of LC, and that value we can measure in hertz. So this you have to take into account, that what is the unit of a particular we can say resonant frequency. Either it is omega R or it is FR. If it is omega R, we will measure it in radians per second. And if it is in hertz, that means it is FR 1 by 2 pi under root of LC. So this is what we can say need to remember, that what if anybody asks you what is the value of the resonant frequency in hertz, so the value of that in hertz in terms of omega R is equal to 1 by under root of LC, and if you are talking of FR, that is the resonant frequency in hertz, then it is 1 by 2 pi under root of LC. Okay, this you have written. This is clear to everybody?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now we will talk of again these plots. Means we will one by one discuss that how these parameters, that is the reactance, then the inductive reactance, capacitive reactance, how these parameters they are related to each other, or we can say how they vary with frequency. Obviously, whenever we are talking of, I told you, we are talking of the instantaneous values in case
Mhm.
of AC. Okay, so in case of AC, if you talk of instant, that means we need to consider, we need to take into account the values of, we can say, at every instant of time, or here we are talking of frequency for that matter. So we need to consider all these values at every instant of this time. So for that, if you talk of the reactance first, that is X, which is equal to omega L minus 1 by omega C. That means it will depend upon what parameter? It will depend upon frequency. It will depend upon frequency. That means the variation of XL. Now this you have to understand, XL and XC, because that value is X, which is the reactance. Now we want to see that how this reactance is related in terms of inductive reactance and in terms of capacitive reactance. Now you can see, if you talk of the reactance, that is the inductive reactance XL, all of us know which is equal to 2 pi F and L. That means these two are directly related to each other. Are they or not?
Yes,
Correct.
ma'am.
Yes, ma'am.
Yes,
That
ma'am.
means,
Yes, ma'am.
if you talk of XL with respect to F, the variation of inductive reactance with frequency, that's a straight line, means it is directly related. If you talk of XL, it is directly proportional to F. है कि नहीं? ठीक है? That means it increases linearly with frequency. So if you are asked to, we can say, draw a graph or make a graph between the inductive reactance and the frequency, it will be a straight line. Clear to everybody?
Yes, ma'am.
Yes, ma'am.
Now second
Yes,
part,
ma'am.
take the second point of it, or the second portion of it, that is XC. Now you talk of the capacitive reactance. So this capacitive reactance again is equal to 1 by 2 pi f. That means it is inversely proportional to the or we can say it, the graph would be something like this. Is it clear? It will be xc is equal to 1 by 2 pi fc.
Yes, ma'am.
Means it decreases with the frequency and is largest at lower values of frequency. So these three things you need to, two things you need to, we can say, remember in case of the reactance of the circuits. Fine. Now you can see one more graph, that is the variation of reactance and impedance with the frequency. Firstly, we had discussed about two parameters with frequency. One was the inductive reactance, that was XL, and another was XC. So we saw that in case of XL, that was directly proportional, or we can say that was increasing with the increase in the value of frequency. And in case of XC, it was just opposite to that of XL, which was 1 by 2 pi FC. Fine. Now, if you see to this graph, in which we are varying many parameters we have shown over here. So first parameter, that resonant frequency, Z is equal to R. This is clear to you? It is a purely resistive one.
Yes, ma'am.
That means if you talk of
Yes, ma'am.
resistance, this line, this one, this line, let I name it as line number 1. So if I talk of the resistance, it is irrespective of change in frequency. That means it will be a straight line parallel to x-axis. Is it clear to everybody?
Yes,
Yes,
ma'am.
ma'am.
है ना? अगर
Yes,
आपका
ma'am.
ये फ्रीक्वेंसी है, ये एक लाइन होगी, it will be just parallel to x-axis. That means this is R. It is purely resistive, which is independent of frequency. So it will be a, अगर आप कोई भी पूछ रहा, so you can just understand it well, that it is a straight line parallel to this axis. So this is R. So R stands for the resistance over here. Fine. Now, when we see this particular value, that is the XL, that also we had discussed, it will be a straight line. Okay, it will be a linear, we can say, relation between, it will be with linear relation between this and frequency. So this is your XL, which is a straight line. Okay, this is also clear to everybody. Now comes the third
Yes, ma'am.
parameter, that is xc, that is in the fourth quadrant we can say. So that is your xc. Now, if you talk of the impedance, or we can say the z, so it will be, we can say, decreasing till the point of resonance. यहाँ पे आपकी resonant frequency होगी. At that time it will be zero, because at that time it will be equal to R, or we can say it will be purely resistive, and after that it will go on again increase. ठीक है? Okay. So that is about these two parameters. Now, seeing to the phase angle, that was about the amplitude, and we had discussed about different, we can say, variations with respect to frequency. Now, if you talk of the phi will be simply tan inverse xl minus xc upon r. If you see here, xl minus xc, that means z will be the, we can say, resultant of this particular condition when xc is greater than xl. ठीक है, that means below resonant frequency, lesser than resonant frequency. Okay, phi will be negative, means circuit will be passive. Okay, and at resonance when xl is equal to xc, so z and r will be same. Is it clear?
Yes, ma'am.
है ना, क्योंकि ये आपकी रेजोनेंट कंडीशन आ जाएगी. Now above, that means when above FR frequency, above the resonant frequency, as you can see in this graph also, this is the point for the resonant frequency. Okay, below this and above this, so it will be Z, this will be XL. So same thing is being described here also. Here we can say XL will be greater than XC. That means this will be XL minus XC. यहाँ पे this will be XC minus XL, means L is lesser, here C is lesser. So in this case we can say at resonant frequency phi is equal to 0 and circuit will be purely resistive. ये तीन चीजें आपने याद रखनी है. Below resonant frequency XL will be less than XC, that means phi is negative and circuit is capacitive. At resonance it will be purely resistive. These 3 points you need to remember. It will be purely resistive, and above frequency, that is above resonant frequency, the circuit will be inductive. Is it clear to you, this point?
Yes,
Yes,
ma'am.
ma'am.
Okay, so this thing you have to remember. So firstly what you need to understand in this is the, what do you mean by resonancy, then what, how can you calculate the resonant frequency in two terms. Then we can say what are the different relations of frequency parameters with these parameters with frequency. Then we can see a graph, that is the variation of resistance, reactance, impedance with frequency. ये आपको आना चाहिए. After that we can see the phasor, or we can say the phase of the circuit impedance, which can be given by these three parameters. One is if the resonant frequency is below FR, at that time circuit will be capacitive. When it is purely, we can say, at resonant frequency where XL is equal to XC, at that time it will be purely resistive. And third condition, when it is above FR, it will be purely inductive. Right? Now, simply this current we can calculate V upon Z, V angle phi upon Z, or that is simply the maximum value of the current will be there at resonant frequency. So that means if you talk of this particular graph, इसमें if you need to draw or add the current graph, that will be something like this, which will be maximum at resonant frequency. Is it clear?
Yes, ma'am.
ठीक है ना? That is what is being discussed over here. If you talk of the current, it will be maximum at resonant frequency. Obviously it will be maximum where omega is equal to 1 by omega c, means, and when obviously it will be resistive, so Im is equal to V upon R. ठीक है, ये आपका जो मैं अभी बता रही थी, एट मैक्सिमम एट रेजोनेंट फ्रीक्वेंसी वी कैन से दिस विल बी लाइक दिस, और आपका जो इम्पिडेंस का होगा इट विल बी समथिंग लाइक दिस. इज इट क्लियर?
Yes, ma'am.
Fine. So you
Yes,
can
ma'am.
understand it. This will be for current now, and this will be for, okay. and this quality factor we had discussed yesterday also. Okay, that is the sharpness of the resonance in a resonant circuit. Means ये जो आपकी peak है in a resonant circuit, what is that peak or what is that sharpness of the peak? So that resonant circuit may it's measured with the help of the quality factor. And that, of course, I told you it is the peak energy stored divided by energy dissipated at one period. That we have discussed yesterday also. So this we can just write down in case of RLC circuit. ये आप लिख भी सकते हैं expression को 2 pi 1 upon Li square, that is the energy being dissipated, and that amount of this expression that we are saying peak energy stored and energy dissipated. Okay, this is 1 by 2 Li square, 1 by 2 I square R into 1 by Fr. So this is 2 pi Fl divided by R. Okay, or we can say omega L that I told you, just opposite, that is Z upon R. So we can say it is omega R L upon R, 1 by omega CR also, and Q can be taken as 1 by R under root of L upon C. So you can just note down and remember these expressions for finding the quality factor. Is it clear?
Yes, ma'am.
Yes, ma'am.
So
Yes,
these
ma'am.
are some of the we can say points we can discuss about the resonance in the RLC circuits. तो आप इसको ऐसे भी ले सकते हो, reactive power, average power, but you need not go. You can just remember these expressions and the main formula, that is this. Okay. And about the voltages, we have already discussed this phasor. You can understand, you have already discussed it, that if you talk of the voltages when capacitive, that means current leads the voltage. So you can just remember VC minus VL. So VR will be the resistive voltage, and this will be the we can say the resultant voltage. Similarly, if it is resistive, that will be in phase. So both of them will be in the same phase. There won't be any phi. The value of phi will be equal to 0 in this case. And if it is inductive, obviously current will lag. That means this is voltage, this is current. This is okay with everybody?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
So this was something I was talking about, the variation. So this is your frequency variation with respect to the, means what is the range or what is the sharpness of that resonant curve. Okay. हाँ, ये आप पढ़ सकते हो. What do you mean by bandwidth? That is not वैसे given, but we can skip it up. Not that much required. That's all. So that was about this resonance circuit. Is it clear to everybody? So you need
Yes,
to
ma'am.
remember, I will again
Yes, ma'am.
repeat it. I'll again repeat it. You need to remember about the resonance circuit is firstly what they mean by the resonant condition in terms of XLXC, you can say. Then we can say how to calculate the value of, I'll just summarize these points, just a minute. Just a minute. I'll open one page. Give me 1 second. There's some problem, I'm not able to share. Yes, no, it is okay. Okay, so we have discussed about firstly the definition of resonance. Okay, then we discussed about the expression for resonant frequency, that we discussed in terms of omega R and Fr. So this was in radians per second, and this was in
False.
Okay, so these two things we discussed about these two expressions. Okay, then we said that at resonant condition there will be certain we can say variations with frequency, variation of different we can say values, that is variation of current, all of this frequency. So variation of current we are talking about with frequency. We talk of Z, we talk of R, we talk of XL, we talk of XC. Okay, net reactance. So these are all parameters we had discussed for the variation of these parameters with frequency that we discussed about with some graph. So this was the value for the resistance, we could say, which was independent of frequency. We talk of the impedance, it was minimum, we can say at, if this is some point we call it as resonant frequency. This was below the resonant frequency, this was above resonant frequency. So these are parameters. This is R, this was say said, and for that matter we could say this is the current or which, and there was a straight line. What was that parameter? That was XL, है ना? And one was XC, which was we can say 1 by 2 pi FC. So these were inversely proportional with frequency. So if you talk of the relations, I can tell you this is maximum at omega r, this is minimum at or fr or omega or whatever. This is independent of frequency, this is directly proportional, and this is this clear to everybody?
Yes, ma'am.
Points. So this we had discussed about. Okay, then we said about something about the quality factor, then how it is related, that we discussed. Okay, so this was all about we can say the resonance circuits. Clear to everybody?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Now I can give you one, just a minute. We can discuss one problem. Just a minute. I'll just give you. So you can write one question, write down. Yes, in a series RLC circuit, write down the question. In a series RLC circuit, R is equal to 2 ohms. Am I audible? Are you writing the question?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
In
ma'am.
a series RLC circuit, R is equal to 2 ohms, L is equal to 1 millihenry, and C is equal to 0.4 microfarad. C is equal to 0.4 microfarad. Okay, find the resonant frequency okay and calculate the quality factor. ठीक है? It's very simple one. You are given with the values of R, L, and C with the value of input, that is we can say V is equal to 20 sine omega t. Okay, So for that, simply, if you need to find omega r, it will be 1 by under root of LC. So L and C is given to you. You can calculate omega r, that is the resonant frequency. Can you do it? Very simple one. Yes, you people are able to do it.
Yes, ma'am.
Okay.
Yes, ma'am.
5
Hurry
into 10 to the power 9.
up. So what about resonant frequency? What's the value?
50 kilohertz.
Yes. Is it in hertz or radians? 50.
मैम
Radiance per second.
रेडियंस
Radians per
Radiance.
second. Okay. So यूनिट मैंने इसीलिए पहले बताया आपको, दोनों चीजें क्लियर की. हर्ट्स है या रेडियंस पर सेकंड है, मेक इट क्लियर. And what about the quality factor? So that value is equal to
1.
Okay, everybody is getting the answer? Yes, what about others?
Ma'am, is it 1?
Yes, yes. Okay, so these are some kind of very simple, we can say, kind of problems that you can deal with. And what about the other ones? I can tell you. One more I can give to you, just a minute. From next class, we can start with the balance three phase. Just a minute, I will give you. Okay, we can start with the next, that is your topic in the next class. That will be regarding your three-phase circuits. So till then, can anybody tell me, if I will just summarize that, what about the three-phase circuits? Just a minute. So this is clear to you till this?
Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes, ma'am.
And we will just go with some of the basics, and in next class we will start with the chapter. Can you tell me, we call 1, 5 and 3, 5. Do you know the difference between the two? First we discussed about difference between AC and DC. Okay, we discussed about these circuits which were independent of frequency. Then we discussed about the circuits that is dependent on frequency in AC. Now we are talking of single and three phase. Means it will be having one phase and one neutral. Okay. And here in case of three phase, single phase was that we were discussing till now. Now in case of three phase, the complication has increased a bit. Means we will be having three phases now. And is it clear? ठीक है. That means previously what is our generation of power? That is always in case of this three phase. Means we have three phases which we denote by. This is clear, known to anybody. We denote the base phases by these names: red, yellow, and blue, RYB or ABC. Is it known to anybody? Do you have any idea about it?
No, ma'am.
Okay.
No, ma'am.
Generation is being done that has three phases. Means the input they are being given in, we can say it's a three phase, four wire system. This is R, this is Y, this is B, and this is neutral. So we call it as three phase, four wire system. ठीक है? Means these three will be giving the input and this will be your phase. And based on this, we can say in case of, we can do it in two ways. Either we can have three single phases to make one three phase. ये बात समझ आई? We can do this also. ये बात समझ आई? This line I have written. Is this line clear to anybody or not? Means we can make
Yes, ma'am.
this in two ways.
Yes, ma'am.
Either we can have one three phase circuit or we can have three
Three
single.
single phase.
ये बात समझ आ गई?
Yes,
By
ma'am.
synchronizing them
Yes, ma'am.
with each other, we can make a three phase, or we can have a single three phase. But this has certain advantages over this. Okay, that's why if we have a machine or we have an input we require three phase, we go for this as compared to that of synchronization of these three. Okay, fine. Now here comes the main thing, or the thing that we need to discuss. These are balanced three phase circuits. Means basically there will be some loads on these phases, and if that load is, we can say, same in all the three phases, we call it as a balanced three phase circuit. And if such is not the condition, we can call it as unbalanced. But what we is given in our syllabus is balanced three phase circuit, so we need to discuss this. For that we can, I can tell you, जैसे हम सिंगल AC की बात कर रहे थे और सिंगल फेज AC की बात कर रहे थे, there we were saying two parameters. One was the phase and one was frequency. We were saying single phase 50 hertz. So we were talking of 220 volt, 50 hertz, single phase supply. ये clear है? This was the input information, say regarding the voltage. Is it clear?
Yes, ma'am.
Yes, ma'am.
Case of three phase, single phase. Now, if we talk of three phase, here we will be having three inputs or three phases. That means now voltage will be having three phases. One will be voltage VA, or we can call it as R, ABC or RYB, which be, that is the nomenclature, and VC means three voltages will be there. And all of them will be related to each other. The magnitudes, say that the magnitude, let it be VP magnitude will be same, but what is different or what will be varying in this particular case will be the angle, VP is magnitude. ठीक है? Say if you are talking of phase 1 VA, ठीक है ना, that is first one, इसका हम लिखेंगे VP magnitude with angle 0. You are talking of the voltage of another phase, that is say VB, it will be again VP, that is the magnitude, but it will be, we can say, having a phase difference of 120.
Minus 120.
If it is VC, the third phase, again we can say the magnitude will be say Vp, but its phase will be.
Plus 120.
ये बात समझ आ गई? अब here in this diagram you can see if these three are the phases, they will be apart from each other by an angle of. Is this clear? This is the phase diagram
120.
for these three I have given. Means if you start from here clockwise, this is A, this is B phase, this is C phase. Now is it clear? It will be moving something like this clockwise. And summation of all these should be equal to,
0.
0.
then it will be a balance.
Zero.
Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay, so this is
Yes, ma'am.
something introduction that we can understand regarding the three phases. Okay, अब हम इसको डिटेल में पढ़ेंगे in your next class, but till then you can just remember if you are talking about this, so it will be some voltage which will be having same magnitudes, but your angles they will be different. They'll be at an angle of at a phase difference of 120 degrees. Clear?
Yes, ma'am.
Okay.
Yes,
हाँ.
ma'am.
थोड़ा सा इंट्रोडक्शन पढ़ लीजिए अपनी बुक से. In our next class we will be starting with this topic. Okay, we also call them polyphase sometimes. The one more name given to it is, we can call it as three phase, or we also call it as polyphase. In some books you may see the nomenclature as polyphase also. Okay, so this is also a name given to it. Right, so we'll be again starting in the topic in the next class. Till then, just practice your questions and all. Okay.
Excuse me, ma'am. Ma'am, I have a single doubt that in ma'am, apparent power or a passive power and a active power, the currents we have to find by using the net impedance, na?
Yes, the active component, that is the cos component of it. And if you talk of sine component, that will be the reactive component. I sine phi, I cos phi. Cos phi will be the active component of it. Sine phi will be the reactive. And apparent is the resultant, that is S you have taken. In terms of Z, जैसे मैंने आपको कल बताया था, it will be P and Q. Or in terms of Z, if you talk of P is equal to I square R, then Q is equal to your this, and Z will be the resultant of these two, that is R and X. Or we can
Ma'am,
say
yeah,
P and Q,
yes.
resultant is S. Okay, apparent power.
ओके मैम. मैम जैसे
Well,
उसके अंदर z इक्वल्स टू आई स्केयर आर है, तो मैम
हाँ
उसके
जी,
अंदर
हाँ
आई
जी.
जो होगा वो वी वाई जेड वाला ही करंट होगा ना
Yes,
मैम
yes,
हमारे पास.
yes, 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 yes.
ओके मैम, थैंक यू.
Okay. Okay, then you can just write your attendance in the chat box. Everybody write down.
Thank you, ma'am. Thank you, ma'am.